A factory floor. A folder of paper. Hand-scrawled I/O lists, photocopied wiring diagrams with the coffee stains still on them. A whiteboard nobody's photographed in over a year. This is how most industrial automation still gets documented, or doesn't. We gave that exact mess to VibIntu. One color sorting system, a stack of unorganized paper, inputs and outputs scattered across handwritten notes, half a speck living in someone's head, the rest nowhere at all. Watch what comes out the other side. VibIntu reads the paper, every page, every scrawled note, and starts asking the questions a real engineer would ask first. What are the inputs? What are the outputs? What type is each one? Digital, analog, a safety circuit that can never be bypassed. It builds the complete I/O table before it writes a single step of logic, because a control system built on a guessed input type is a control system that fails on the floor.
Then it builds the operating modes: production, manual, fault, emergency stop, restart, reset, as a proper GSRSM state machine, structured the way a senior automation engineer would structure it, not the way a junior one would guess at it. And then, in parallel, however many specialist agents the job actually needs, with no ceiling on how many can work at once, it writes the sequential function chart for every single mode: steps, transitions, actions, interlocks, fully documented, fully typed, fully compliant with the standard. Work that used to take an automation team months, done before your coffee gets cold. But here's what nobody else does. It doesn't just generate a diagram, hand it to you, and hope it's right. Watch it check its own work. Every mode has to close the loop. Production has to be able to reach fault, fault has to be able to reach reset, reset has to be able to return to the exact state the system started in. If a transition doesn't close that loop, VibIntu doesn't ship it. It catches the gap, rebuilds that section of the logic, and re-verifies it, automatically before a human ever sees the draft. This isn't a chatbot guessing at a diagram once and moving on. It's an engineer that checks its own homework every time, until the logic actually holds. Then it goes one step further than checking the diagram. It runs it. A live simulation driving real inputs against the exact logic it just built.
Welcome to
Press the start
VibIntu.
button.
How can I help
Trip
you
the
today?
emergency stop.
We can have the engineering swarm build a project in the background, use the computer agent for UI tasks, or I can generate a project story for you. What's on your mind?
First, I want you to navigate to A5 SFC.
So you want me to navigate to A5 SFC. Should I go ahead and dispatch this to the computer agent?
Yeah, go ahead.
Request dispatch to the computer agent. The computer agent is currently performing a click action. A2A context. I've evaluated step 2, but the screen is still identical. It seems my click was not registered correctly or was on the wrong element, so I'm reevaluating the next steps. A2 context. The computer agent task is complete.
I want you to explain the action associated to step 1.
Based on the A5 default.sfc shown on your screen, step 1 has one primary action, light fault R. The -n modifier indicates that this action is non-stored, meaning it is only active when step 1 is currently active.
I want you to generate a full report about this project.
So you'd like a comprehensive project report generated. Should I go ahead and dispatch this to the storyteller agent?
Yeah, go ahead.
Great, I'm dispatching that request now. The storyteller agent is now generating the creative assets, including 2 images and 1 video for the report.
In modern logistics hubs, automated conveyor sorting systems represent the backbone of fulfillment velocity.
Months of engineering compressed into 1 hour with a workforce of agents that scales to however big the job is. This isn't a tool that helps you write automation logic faster. This is the first industrial automation vibe coder. This is VibIntu.